All right, let's take a look at Nitro 7.6, which is about two different sorting algorithms, mainly the selection sort and the insertion sort. And in 7.6.4, all they want us to do is count the number of swaps. So we just got to figure out in this code, which is not in the main. They even say don't add anything to the main. So they already created the algorithm called selection sort. And it says right here, print out the number of swaps that took place before returning the array. So as we're going through the array, right here you can tell by their comments, it says swap numbers if needed. But also this little helper variable temp is kind of the tip-off that this is where the swap is taking place. Save current minimum index into temp, update the array at the current minimum index, and then I equals temp. So we need a little variable to count the number of swaps. So very simply, integer num swaps, and start it off at 0. And then in here where you're swapping the numbers, just say num swaps plus plus. And then right here, system.out.println num swaps. So notice the first array that was perfectly backwards only required 4 swaps, because when you do the selection sort, you're comparing this 9 to the whole rest of the list, and you're finding the minimum in the whole rest of the list. And when you find the minimum, you swap that with the 9. But in the first array, that means the 1 is going to be in the right spot and the 9 is going to be in the right spot. So that only requires 4 swaps. The second array that's more of a random mess, that one's taking 8 swaps. But that's all they wanted us to do there, is just count the number of swaps required. And then let's move on to insertion sort over here. So same 2 arrays, I believe, and what they want us to do here is change the code to sort in descending order. All right, so let's begin this insertion sort with a loop for int I equals 1. We're going to start at 1 because we're going to assume that the number at index 0 is already sorted, and I less than the array dot length and I plus plus. And every time through the loop, we're going to save what we're going to call current number, which is the number that's in the array at index I. We're saving that as current number. And then a new index other than I, which we're going to call current index, and that's going to start off at I minus 1. And then we're going to do this while loop. While the current index is greater than or equal to 0, and the array at the current index is greater than the current number. As long as that condition is true, this is what we're going to do. We're going to copy the current number over 1 spot. So we're going to make the array at the current index plus 1, that's over 1 spot from where we are now. We're going to make that equal to the array at the current index. And then we are going to decrement the current index counter. And then once we get done with that while loop, then the array at our current index plus 1 will equal the current number that we saved earlier. So let's take a look at what that would look like with a small array of numbers. Let's say we have these numbers here. So our I is at 1. Our current number is at the array at index 1, so that's the number 2. Our current index is I minus 1, which is 0. So the current index is greater than 0. The array at current index 0 is 5, and that's greater than the current number, which is 2. So here's what we're going to do to the array. The array at the current index plus 1. So current index is 0. The array at the current index plus 1 is going to equal the array at the current index, which is index 0, which is 5. So that 5 gets put right there. That's what I was saying about moving that over 1. So we're basically moving or copying over that 5 one spot. Then, so after that's been done, then the current index gets decremented, which means now it's -1. And then our while loop says, while the current index is greater than 0, and it's no longer greater than 0, so the while loop is done. And now we're going to say the array at the current index, -1, plus 1, which is 0, equals the current number that we saved earlier, which is 2, which means this now looks like this. So that just put the 2 in front of the 5 the first time through the loop. Next time through the loop, I is 2. What we're calling current num is the number in the array at index 2, which is the 4. And the current index is I minus 1, which is 1. So while the current index is greater than or equal to 0, it is. And the array at the current index, the array at index 1, which is 5, is greater than the current number, which is 4. So all of that's true. Then do that copying that we talked about earlier, except now we're copying the item that's at current index 1. We're copying over to current index plus 1, which is 2. So now the array looks like this. And then current index gets decremented. So current index is now at 0. And we go back up here again. Current index greater than or equal to 0? Yes. The array at the current index, so the array at 0 is 2. Is that greater than the current number? No, it is not, because the current number is 4. So we're done with the while loop. And then we come down here and do this statement, which is the array at the current index. So our current index is 0. The array at the current index plus 1, which is this one right here, equals the current number which we saved earlier as the number 4. So that gets moved over to there. Okay, so then after that, what's going to happen is, now I is going to be 3, and the first time through the while, the 5 will get copied over to here. And then the next time through the while, the 4 gets copied over to here. And then the next time through the while, the 2 gets copied over here. And we went all the way through the loop. And then finally on the last step, the 1 gets placed here. So that should put the numbers in numerical order. So if we implement this right now, we need to return. Okay, there we go. So first array sorted, second array sorted. So that's working great. But they wanted to sort in descending order. So the only thing we have to change to make it descending order is make this right here less than. If we make that check less than, then they will both be in descending order. And that's what we had to do for 7, 6, 9. Okay, so now on to 7, 6, 10. And all they want us to look at here, there's not really anything for us to do as an assignment. They're printing out the nanoseconds that it takes for each of the sorts. So if you have a reversed array, the two methods, selection sort and insertion sort, are almost identical. 120,000 nanoseconds versus 140,000 nanoseconds. Selection sort is slightly faster, but not by much. But when you have an array that's almost sorted, and just to show you what they mean by almost sorted, all of the numbers in order are in order except for the 99. So when the array is almost sorted, selection sort takes this many nanoseconds, but insertion sort takes this many nanoseconds, less than 1/10 as much time insertion sort takes when the list is already or almost already sorted. So nothing special that they wanted us to do there. Okay, then over here we have this PhoneBook app we need to work on, and this is a little bit more involved. So they are adding some names and numbers to an object that they've called PhoneBook. So they already created for us a PhoneBook class, which has instance variables for the name and the number and getter methods for the name and the number. But they're creating a PhoneBook object, and so we have to write the PhoneBook class. You see it's very empty here. The first thing they ask us to do is to create a private array list, or an instance variable array list, of object phone number. So an array list of phone number objects. I'm going to call it this book. New array list of phone number objects, and then the double parentheses to end that. Okay, and then we don't really need a constructor, but we need 3 methods in the PhoneBook class as they're describing over here. First of all, we need a method called add number. So we're going to say public void add number, and all the add number method is going to do is it's going to take our current phone book, which is called this book, and add a phone number that is passed to us as a parameter. So I'm going to call it digits. Okay, so this book add digits. That's pretty much all we have to do, except then after adding that, we want to sort the book, or this book. So that means we need a method for sorting our current phone book. So public void sort. This is going to be the tough part here. And then we need a print phone book. That one's pretty simple. Public void print phone book, which is pretty simple. For int I equals 0, I less than this book dot size I plus plus system dot out dot print line. So this book is an array list of phone number objects. So let's get the object at location I, and once we have that phone number object, let's get the name of that particular object, and that's what we're going to print out is the name. So hopefully this will run without error. It's not going to do everything that we need it to do yet, but that will at least print out the names in the phone book. And of course our goal here is to implement this sort method so that we can have that phone book in alphabetical order. But the names that they wanted to add to the phone book over here, the new phone book object is being created correctly. These names are being added to that phone book correctly. So all of that part of it is working fine. So now to implement the sort. And they mention over here the PhoneBook sorts after each add, then the list will be sorted completely except for the new entry. Which sorting method should you use? And we were just taking a look at that insertion sort is the best for doing that. So just to remind you what the code looked like when we did insertion sort a couple lessons back, our insertion sort method looked like this before, but the problem with this is that we're trying to do a sort now on an array that is an array list of phone number objects as opposed to a regular array of integers. So we're going to have to implement a little bit different scenario here, but just to refresh your memory that we're looping through the entire array and then saving the item at the current location and then going through all the items before that to see where it should be inserted. So that's what we were doing previously for insertion sort. Now we have to do that with phone number objects and with strings for names as comparison. So we're still going to have that loop. Okay. So we're still going to have that loop, except now the loop is going to go up to this book dot size, since it's an array list. Okay, so this is our standard way of traversing the array list, and we're going to save a couple objects before we start moving stuff around. A phone number object called digits I is going to save the phone number entry in the phone book at index I. And then a string called name I is going to save the name that's associated with that phone number object that we just saved. So digits I dot get name. So that we have that as a string to do a string comparison in a little bit. And then just like the insertion sort that we did with integers, we're going to say current index is I minus 1. Okay, and then while a certain condition is true, we're going to do some stuff. And that condition, the first part of it is going to look like what we saw before, while the current index is greater than or equal to 0. And then our string comparison, which is going to get a little bit lengthy. So I want to compare the name of the phone number object that we get from the current index of the phone book. So I want to say that the array list dot get the phone number object at the current index, and on that object get name, and now that's a string, so on that string dot compare to, and compare to what? Compare to name I that we saved earlier. And if that comparison is greater than 0, then we want to copy stuff over. This book dot add at the current index plus 1, this book dot get the current index. So that step right there does this. So we just added Dylan to the list. I is 1. The name at location I is Dylan. The current index is I minus 1, which is 0. So here's what we're doing to the list. The phone book at get the item at index 0, the name for that item is Shelley, compared to Dylan is greater than 0. So we're going to copy Shelley over. And the way we're going to copy Shelley over is we're getting the item at the current index, which is Shelley, and we're adding that item to the current index plus 1, which gives us this. Then we need to get rid of something. So this book dot remove the item at the current index plus 2. So the current index is 0. You just moved that item over to index 1, and now we're going to remove the item at index 2, which means now this list temporarily looks like Shelley Shelley. And then we decrement our current index. So now the current index is -1, which means it's no longer equal to 0. So we've come to the end of the road with the while loop. So then what do we want to do? We want to put Dylan in the beginning of this list, but that's going to be accomplished in general by saying this book dot add at the current index. But remember, our current index is -1, so we want the current index plus 1. We're going to add this item that we previously saved, which is digits I, which is basically Dylan. So we're adding Dylan at index 0 in this case, and then we also have to remove this book dot remove. We have to remove the item at the current index plus 2 again. And the reason why it's not plus 1 is because we just made the list longer. So this Shelley was appearing twice, and so that's at, this is current index, this is current index plus 1, this is current index plus 2. So now Shelley at current index 2 gets removed, and the list looks like that. Okay, now let's look at a little bit more lengthy example. Let's say now our list looks like this, and Kevin is added to the list. So once again, I equals 1. The name at location I is now Shelley, and the current index is I minus 1, which is 0. So we look at the item at the current index, which is Dylan, and we compare that to name I, which is Shelley, and that's not greater than, so we don't have to move anything. So therefore the while loop is not going to execute. And what we're going to do, what we'd kind of like to do is nothing, but in reality what's going to happen is we're going to add that name I, Shelley, we're going to add that at the current index plus 1. So current index is 0, so we're adding Shelley right there, and then we're removing Shelley from the current index plus 2, which is that, which means we're back to the original list. We basically took no action, but that's the way that we took no action. But now, that's the first time through the for loop. Now I is 2, and the name at I is Kevin. And the current index is I minus 1, which is 1. So now we're comparing the name at the current index, which is at 1, which is Shelley, comparing to name I, which is Kevin, and that is greater than. So now we're going to do this stuff in the while loop. So we're going to add, remember our current index is 1, so we're going to add at 2 the item at the current index, which is 1, which is Shelley. So Shelley is getting copied over there. But then we're going to, on the very next step, we're going to remove what's at current index plus 2, which is at index 3, which is Kevin. So Kevin is temporarily off the list. Shelley is in twice. But that's what we were doing with integers, is copying from one location over to the next location. Okay, and then the current index goes down by 1. So now we compare the item at the current index, which is Dylan, and we're comparing that to name I, which is Kevin, and now Dylan is not greater than Kevin. So this while is not going to execute, so now the stuff outside of the while is going to execute. At the current index, which is 0, plus 1, which is 1. So at location 1, we're going to insert Kevin. So at location 1, we're inserting Kevin. And then at location current index plus 2, which is right here, we're removing Shelley. Shelley just got moved over 1 when we inserted Kevin. So now we're removing that Shelley, and now the list is sorted. So we should see when we run this, we should see the list of people in order. And if we check our code, then we got that. And if we can mess around with a little bit if we wanted to, we could come over here and add a new number. This is from a very famous song that a lot of you probably don't know, but I'm going to add a phone number called Jenny, and we're going to make the number 8675309. And this should also sort, I don't want to check code, I want to run my code. That will also sort Jenny in the correct order in the list. But of course, if I have Jenny, then it's not going to pass my code checker over here. So that's it for Nitro 7.6.12, which means that's it for Nitro Unit 7.